Hey, hello everyone. So here, hi. So sorry for the delay. I had a small network glitch. I'm extremely sorry for that. So we'll start it now. Hope I'm audible. Yeah, yeah. So good afternoon, everyone. So let's get started. And first of all, welcome you all for the our first webinar. So yeah, my name is Karthik. So I'm the founder and CEO of Mydbops, and I have around 11 years of experience in MySQL and its related technology, and I have worked in Yahoo before. So coming to Mydbops, so it's a 5-year-old organization, and we support various organizations in the Indian subcontinent and abroad also in US and Gulf also. And we are one of the certified AWS partner, and we are also a PCA compliant one. Yeah. So when it comes to MyDBOps services, these are two things we do. One is the database consulting services, and other is the managed database services. And we provide this support and services for the top three databases like MySQL, Mongo, and Postgres. So initially we started as a MySQL shop, and then later we adapted MongoDB in 2017, and we got adapted the Postgres in 2020. Yeah. So yeah, so this is my audience. Yeah. So let's get started. So MySQL HA solutions. Everybody loves a HA solutions. So everybody love HA solution. So availability matters in all the systems. It can be a DB system or the app systems, and the database application. This plays a very major role. So when it comes to high availability, traditionally replication, right, is the one of the major high available solution. Like we call it as the mass slave or the source replica. Now it is called the source replica. That's one of the very basic or the simple method of HA solution. So native replication. So native replication is, as we all aware, it's based on the asynchronous or the binary log based replication. And then there are multiple things can be done in native replication, like you can call it as a master or a master slave or a source now it is aware, or a cascade replication, filter replication. Those things are always possible with the native replication. And MySQL replication is one of the strongest, you can say, even from the very like 5.0. It's very pretty stable. Well, compared to other database, right, we have a native logical replication. That's the important thing. And then comes the group replication. Of course, we have something called NDB cluster. Not going to cover that part. And then comes the group replication. So it it was designed to overcome the problem with the native replication. In native replication, we can have lags. So this was about to try to solve these problems. Okay. Yeah. So what is InnoDB cluster again? Yeah, InnoDB cluster, when you call InnoDB cluster, it's not a single component. It is a combination of multiple components like MySQL shell, router, and the MySQL servers. Of course, with the group replication enabled. So need for MySQL shell. So MySQL shell, as we all know, it's a utility where you can use it and configure the service very easily instead of making a manual installation or a manual configuration. This makes things much simple. And MySQL router is, you can say, it's a load balancer, comes with the MySQL, like it works like a TCP level, like a HA proxy. Don't have the SQL intelligence, but it does the job of the switchover and failover really efficiently and gels well with the group replication. So fine, yeah, notable cluster and its components. So when I say MySQL servers, here if you observe, I have said servers. It means that there are many components in like Not only a single node can form a cluster, it needs a 3 node, a minimum, to get started. Okay, and they should be running in a group replication fashion. Fine. So in order to cluster, say the cluster, right? They are synchronous replication. It means eventually they will get synchronous, that we will discuss later why it is called eventually synchronous. And they support single primary and multi primary modes. So you can write from any node and read from any row. So that's what it is. Or you can still use a single node as a primary, and then you can read from all the other nodes where you get the synchronous data set. Okay, yeah. So optimistic transaction logic. So this is something different. It's like this is a feature you can say. Traditionally, what happens is we acquire the lock and then we make the transaction. But with optimistic locking, we make the write, uh, and only at the time of the commit we try to acquire the lock. So it happens in the distributed computing world. So as we have in the group replication page, this is always, yeah, needed. And group membership service. So we call it as a group view. The group view is the exact right term to be made. So group membership services. So when we have a 2 node, it has such a view or a state. So only based on the view you propose or receive the transactions. But when you add a node or remove a node, these views get changed dynamically. Okay. So that's a group membership service. Transaction ordering. So when you, yeah, transaction, even though you accept rights from multiple nodes, the transaction order is primary. It should be mandatorily maintained, or else you can have conflicts in the data rights. So this group replication also maintains the transaction order. Like given when there is a lag or something else, it maintains the transaction ordering, and it ensures that it goes via only that order. Even though we have parallel replication, everything like that, it goes only by the group communication system. This group GCS. This maintain everything, and this is based on the consensus. So consensus, the term it means it's like an agreement. Like when you propose something like a primary, the others or the reader should accept it. So that's called consensus. Actually, it is a political term where it's used in the constitutions and stuffs. Okay, yeah. So here what we used is a Paxos based consensus. Paxos is a based consent, and we have XCOM. XCOM is the extended communication system. Okay, and as the name itself says, NodeB cluster, of course, it supports only NodeB engine. As MySQL though it supports multiple engines like memory, uh, MySam, and everything like that. It supports when it comes to distributed transaction. NodeB is the only engine it supports. And again, it is a software-based replication. Why I mentioned this, there are questions when people from other technology ask, hey, whether you have a storage-based replication like we have it in the DRDB. It's a hardware-based solution. And when you look at the rack clusters, they have a shared file or other shared storage. So when it comes to MySQL clustering, it's a shared nothing architecture. So it is a software which controls this database replication by the redundancy of the data. And again, it also based on the binary log replication, GCS, and the data is stored and written via only the binary log. And really works good well for the OLTP workload. What it means directly is all the transaction systems can use it efficiently. And what it means, the other side is you can't use it for a heavy reporting system or which involves heavy or huge writes. I mean the bulk writes. And of course, it supports all platforms as MySQL Server. If you, it supports Windows or the Mac OS or Linux, it supports it. But if you look at the PXE or the Galera cluster, which was eventually more popular also, and it supports only the Linux variants of it. So, but MySQL in this case, it supports all these platforms. Even if you have enterprise MySQL and you're in enterprise systems, then you can still use it on your Windows machines too. So, transaction in group replication. So, In a distributed computing or distributed transaction, everywhere it follows a two-phase commit. Even Galera also does it. So what are the two phases? So one is the voting phase and the other is the commit phase. Okay, so voting phase is where, okay, we like the primary. So primary, when I say primary here means the node where the transaction originates or the source of the transaction. When you have a 3-node cluster, when you try to write from all the 3 nodes, the source of the origination is called as a primary. So it means the applications make the changes or then they are made to commit. And during this phase, during the voting phase, right, it sends out the information to the via the group communication to the other nodes. Hey, I have made a changes to this set of rows. Here the voting is only for the right transaction, not for the RO transaction. RO transactions never comes into the picture of when you say two-phase commit. Even though they are transactions, they don't come into the two-phase commit. So these RW transactions, so they get replicated. The first thing is they received the other nodes or the acceptors. That's what the right name they call it here, the leader of the acceptors. The acceptors receives it and they all come to an acknowledgement saying that, okay, this change or this right set can be applied without any conflict. Then they give acknowledgement, okay, we can go for the commit phase. What it means in MySQL is your data get received to the relay log and then it sends a notification. Okay, the data is in the relay log. You can make the commit and we are okay with this right set change. We don't have any additional different data set here and we are okay with this, right? So, and then it triggers the commit phase in the leader. Okay, yeah. So of course it allows the multi-writer mode. Sorry for the typo. And even the quorum has to be maintained throughout for a transaction. So here, what is the quorum? So this is a very generic or very basic formula. How you define the number of nodes? There are sometimes people ask the questions, hey, Karthik, I have 4-node cluster. Now, does it mean that I can lose more number of nodes? No. So that's where the question comes. Is it possible to have a 4-node or a 6-node? What is the tolerance? And the actual is, it depends on the number of failures you can accept. In general, example, if let's say you can accept the failure of only 1 node, then you should minimum have 3 nodes. So F is the failure number of nodes. So then 2 cross 1 plus 1, it's 3. So it's a number of, if you still want to run a system, functional system with the 2-node failures, then the minimum number needs is 5. Even if you have a 6, you can have a failure numbers of nodes as only 2. So that's what it is. So the basic is 3 and 5 and 7. That's it. People, even if you go for an even number of nodes, of course, it can serve the traffic, but it don't serve the purpose of having the increasing number of failure nodes. Hope I made it clear. Yeah. Let's see a small block diagram. Okay, fine. So first it starts with the commit locally. So the right set, right? That's where the right set comes in. So the right set comes in and it can make a commits locally. Okay, yeah. So what is a right set? So I am repeating the word right set again and again now. I have to, what is a right set? So right set, if you look at the MySQL replication, right? Traditionally we have a single thread and then we overcome with a database or a parallelism, database parallelism. And then we come with a logical clock. That's where we group the transactions in the binary log based on some time limits and time ranges. And then you can say right set as a third generation in that case. So what right set says is transactions affecting different rows or tuples can be grouped together. That's what they call it as the right set. Okay. So even it can be a same table. If there are multiple transactions, it can be updating or deleting records in the same table. So if they are not interrelated, right, the row sets are not interrelated, then they can be grouped together and then applied for the parallelism. So that's what is called as a write set. So when the commit is triggered and the commit is different from the write set is generated and then it goes to the other nodes, or the you can call it as the acceptors. In our case, it's the slave nodes. We can call it as the primary and secondary nodes. And the secondary nodes will make a certification. So the certification process happens. So in the certification process, it checks whether the same set of rows are changed or affected by the other transaction at the same point in time. Here the certification happens based on the primary keys. Of course, primary key is mandatory in InnoDB. Actually, in the InnoDB cluster, it is so mandatory. Without primary key, don't work. Okay. So it goes for a certification phase. And if it detects a conflict, right, the certification phase, it rolls back. It rolls back the transaction. Or if there is no conflict detection, yes. If there is no conflict detection, then it goes for the apply phase, or it gives the commit back to the leader saying, okay, this transaction can be applied. Now, this will be in the applier queue of the secondary nodes. Okay. So, and there is, it's in the, yeah. And then it starts applying locally. So that's it. So the two-phase commit here actually means that the data has received the secondary nodes. It doesn't mean that it just get applied to everywhere. Okay, the apply is locally, and the local apply can differ. What it ensures is the data consistency, because even in case of a crash, you can be sure that your data is present in the other nodes relay. So that's a very important thing about this. Hope I made it clear. Of course, if you have any questions, anyone can ask it now. Might be in the question Q&A session. This is a important thing. We will discuss further based on this. Okay, fine. So yeah, let me repeat it. So it receives the local node, that is secondary nodes, and in the relay log, and they are applied locally. So now comes the other question. So when it comes applies locally, right, then it becomes asynchronous. So as it is asynchronous, yeah, to an extent, but not completely asynchronous. We will see that. So yeah, the transactions origin the primary, that is a leader, and the leader requests a commit, and then it goes for the write set. The transaction write set is distributed via the GCOM, and then the certification is made, and then finally they are applied based on the voting. If there is if there is no votes, or if there is a too odd number of nodes, sorry, even number of nodes, then the voting and the writes failures. Okay. So it's applied to the local node, that is it receives in the relay log, and then it sends my acknowledgement to primary relay saying that okay, we can make this commit. So this small image, I picked it from the wiki page. So yeah, the coordinator, yeah, and the participants. So you can consider the left hand is the coordinator. So you send a query to commit, it is prepared, and then yeah, it is saying yes or no, and then it goes to the other phases for the acknowledgement or the voting phase. In the voting phase, if it is got the acknowledgement to yes, yeah, it goes for a commit, or else the transaction should be rolled back, and then finally it is acknowledged. This is a representation given in the wiki page for the Paxos. Always it's a Paxos based. So in the Paxos, what Paxos is actually is there can be only one leader at any point in time. Yeah, in a distributed transaction, everything is based on the time series or the time clock. So of course the other can be a leader, but not in the same point in time. Okay, fine. Yeah. So when the threshold increase, of course, I told there will be a lag. There can be lag. So what is a lag we can afford? That is controlled by the flow control. So the flow control, is an important mechanism, and it does two different jobs. One is the collecting the statistics of the queues. There are many queues, like the applier queue, we have the applier queue and the coordinator queue and the receiver queues. So it monitors the stats of those queues, and then when it crosses beyond the threshold, let's say you have 2000 transactions, you can say that okay, I can afford a lag of 2000 transactions, then of course it's 2000. Then when it tries to kick in that limit, or the limit before that, then the flow control kicks in and it tries to limit the writes. When you consider PXE or the Galera clusters, where it tries to stop the writes, it won't allow any new writes there when the flow control kicks in. But here it tries to slow down the writes. Yeah, the default is the quota mode. So the default is the quota mode where it tries to reduce the write set size so that it can eventually capture, like say, apply it. It tries to reduce the size of the transactions further and further until the flow control is get released. Okay. So it controls the write sets, that you can say that the write sets in groups, right? It will try to reduce or slow down the writes from the master. It means you will take more time to commit than the actual when the flow control kicks in. Of course, there are ways to tune the flow control, like you can control the size of the transactions, or when is the minimum and the maximum limits which should be kicked in, or what is the percentage of writes which should be stalled. It can be controlled. And the consistency. Of course, the other question comes in. So when you read or write from other nodes, right, will I receive the stale data? So how to control the consistency? The consistency can be controlled. So there is a variable called group replication consistency. So the default is the eventually, and there are many other modes like um, there are many other modes also. Example, like in case of a switchover, failure to primary switchover, you have to ensure all the previous transaction that relay logger applied before it makes promoting as the primary. So that's one of the mode, and there are after and before modes also. So there are different modes. What it does is, when it tries to read it, right, when you want the arrow to be consistent, when you enable it, right, your reads will wait until the previous transactions get applied to get the very consistent reads. And when you enable it, the RW, it ensures the transaction applied locally on the other nodes, the previous transactions, before starting the new writes. So this can have latency, but you will get a consistent read across nodes. But when you have very good and fine-tuned system, there won't be of much latency. And one more thing we have to consider is, when you are using this group replication or InnoDB cluster, always use a good load balancer. Okay, in our case, I would recommend Proxy SQL. If you are good with router, you can use router also. So these are the two active load balancer supports group replication in, well, yeah. So let's say the tuning. So what are the tuning applied for? Of course, all the general InnoDB tuning, right? They completely applies for here. Example, your buffer pool size, your log buffer, log file, and transaction flushing, flush logger transaction commit. Of course, you can make it as 2 if you are sure of your thing is that until all the 3 node goes in the same time, you can make it as 2 because already the durability is made by the 2-phase commit. So, but if all the 3 nodes goes down the same time, you might lose a 1 second of transaction. So it depends. So, but making it 2 can give some additional performance boost. And also the replication level tuning, like the panel replication tuning you can make, and your build log should be row. That is a limitation you can say, or it's good to have a row-based limitation. So row-based build log and your build log-based optimization also can be done. And beyond that, and there is one more thing called group replication message cache size. So previously it was 1 GB and it was hard-coded, and later it was made to 1 GB, like the minimum size was 1 GB in 8020. Now in the last release, 8021, they have made it to 128 MB. So this is like it catches the recent transactions. All the recent transactions will be there. And beyond that, you can also have the compressions. The messages, right? The group messages, that is the right side when distributed, right? You can compress it and send it via the network. So it uses the LZ4 compression, and the minimum size for compression is 2 MB. Like if there is a transaction more than 2 MB, of course, you can try to compress it, and it will send it via the network. that is the we are calling about the group communication, this is XCOM. So that can save you in the network if you feel the network is the bottleneck, of course. And also with MySQL, now we have the bin log compression, MySQL 8, that can help. That can help also in those cases because your relay log and all these rights are there. And if you have a huge transaction, I have told you earlier, huge transactions are not a good thing. But if there is a need, and then the huge transaction can be fragmented, it means the bigger transaction is chunked into multiple small things with a common right side or the transaction ID, and then they are applied. We can consider fragmenting the huge transaction also. Okay, yeah. And also there is one more thing called the clone plugin. We have the clone plugin inbuilt, and even the clone that is used when you are adding a new node, or if you want to rebuild a existing or a corrupted node. So you can enable the compression there also as a part of the tuning, so you can make the rebuilds faster. Okay, so let's come to the last slide. Yeah. So best practices, though it claims that multi-primary is supported, it's good to have single primary in most cases. But if you're sure of your application, if you're sure of your application, like you have isolated the rights so that there will be no write conflicts from the application, then single primary, then you can go the multi-writer modes. But single primary is better in most cases, because there are cases where we have seen people using cluster with multi-node rights, but they isolate the rights based on the database level. So if it is it will write to the only to the database A, or node B, it writes only to database B. So the conflict detection will be less. Okay, it won't be there. So avoid having huge transactions, because as we mentioned earlier, the transaction ordering should be maintained. So when there is a huge transaction, then the upcoming transaction has to wait for until this transaction is certified and passed through. And stable network, of course, that matters a lot. So that matters a lot. But if you are feeling that if you don't have a bit unstable network, then try to tuning the timeouts. So we have the timeouts for the health checks and the expel timeouts. So you can increase the timeout a bit before claiming the node to be dead, because in a group replication, it checks the node's health very frequently. And when there is no response for, let's say, X amount of seconds, it calls this node as dead. But if you have unstable network, it's possible to have this kind of latencies. But if you are sure of what you are doing, then you can increase the timeouts, else it will be expelled out of the cluster. And it's more and more stable with 8.0 while comparing to 5.7. 5.7 has very multiple bugs. Of course, they are porting the features back to MySQL 5.7, but it's good to go with the 8 when you want to try a InnoDB cluster area group replication. And always use only with a proxy SQL or MySQL router, because this group replication claims only the replication consistency, but the switchover or failover from the application, right? So it can be done only from our end. So we have to use a load balancer like proxy SQL or router. Yeah, that's all, guys, and thank you. Let's have the Q&A session.
Thank you so much, Karthik. Hi, all. This is Santana here. I head the business development team. So, actually, first of all, I would like to apologize for the delay because though being under the weather, Karthik was able to give an excellent presentation. So right now, we are at the end of the session, and I could see already a question which is asked by Mughis Ahmed. So Karthik, the question which Mughis has put forward to us is: can you give any suggestions about DR for the InnoDB cluster? That is from DC1 to DC2.
Yeah. So there are two things. You can have it as a part of the cluster also, but of course it depends on your network health and the stability. Or else you can have it as a asynchronous replication with, because it's all completely GTAD based. Now with DC2, you have the feature for the automated promotion also. So you can have the three masters and as a one slave. So that can be possible. Or if you want to be part of the cluster, and then there are fine tunings also where you can mention like how much amount of transaction it can lag only for the particular node. So that can be done. Okay, but it depends on your network health and the switchover part. But it's okay to have a sync node if you are sure about it. Yeah. Thanks, Mukesh.
Thanks, Karthik. Mukesh, does that answer to your question? Okay. Mukesh also has one more question, Karthik. What if the primary gets failed?
Okay. So when the primary gets failed, right,
Mhm.
it promotes the other nodes. Okay. Let's say you have three nodes A, B, and C, and there is an order of primary promotion also. Yeah. It switched to another one. So before switching the other one, it checks there are multiple things. Like first thing is if you have a multi-node cluster, like with multiple versions, let's say 5.7 and 8.0, it tries to goes for the higher version, and then it also checks the weightage. If you are given the member weight, it then tries to promote the based on the weight, it tries to promote it. Or else, and another thing is you have the UUID. Every server has a UUID based on the lexicological order. It means it just sort by the order by, and then it promotes that one. Okay, so that's how the promotion happens. It's a lexicological order. Yeah, it's like we have a UID, even though it's a hexadecimal, right? Tries to order it and then picks the first one. Okay. Yeah,
And
Mukesh.
Mukesh also have asked another question, which is, and our replication will break. How can we take off that for asynchronous replication using another DC?
Okay. Yeah. So is this a Mukesh question or Rajkumar question?
It's Mukesh question.
So can you repeat the question? Yeah.
Yeah. So the question was, yeah, and our replication will break. How can we take off that for asynchronous replication, another DC?
Okay. So when the replication breaks, okay. So if the data is consistent, eventually the replication should not break. Okay, then you have to troubleshoot like a normal manner, like how to skip your GTN and everything. But in case of, let's say you have a three nodes, and then you have pointed to only the node C, and then the node goes down. Now you have to repoint it. To avoid the repoint, of course, we can use the automated switchover failure in feature in 8022, or else you have to manually skip it because it's a DTID, right? It knows what is the source of it, and every node has the binary log, and it also has the logsly updates. So the every transaction is there in the all the nodes binary logs. So it will be easy to fix it. Does it answer your question, Mukesh?
Mukesh, I think Karthik has given enough time for the questions. If you still have more questions, please write us to info@mydbops, and we will be able to revert back immediately. And Karthik, we have another couple of questions. One is from Rajkumar. The first one, which he is asking, is on which node we can configure backup. What is the best practice? And the second question is MEB backup or MySQL dump backup. Which one is good?
Okay. So there is no specific like which node we can configure the backup. So when you have a least production hours or a non-peak hours, you can configure the backups. But even though the writes happen in non-peak hours, don't use a MySQL dump unless you are sure of it, because it can lock it. It can lock your tables before taking a table. So even if you're non-peak hours, so it can be non-peak hours, not a zero production hour. So there you can have a locking and stuff like that. So you can use MEB if you have an enterprise customer. You can use MEB. That's good because MEB has a better features with InnoDB cluster, so, and also it has a better incremental backups. Also, they use this page tracking mechanism really well. You can use it, or if you are in open source, you can use extra backup, and those really works well. Okay,
Okay.
thanks,
Okay,
Rajkumar.
we have one more, request from Vipur Krishna. I have a question, but I need to explain that question. So, is it possible for me to talk instead of just typing the question?
Yeah,
So let me
yeah. Please.
unmute Vibor. Okay, Vibor, over to you.
Yeah, hi, Vibor.
Hello, hi Karthik.
Yeah, how are you?
Yeah, I'm fine. Thank you, Karthik. How are you?
Yeah, I'm doing great.
Great. Karthik, my question is that now that when we are in this cluster combination, so we have two servers which are working continuously or simultaneously
Okay.
together. Okay. So one my database one will have entries, like the first entry will go to database one and the load balancer automatically will put the second entry in database two.
Okay.
So my DBID one is in database one and DBID two would be in database two.
Okay.
Now the third transaction will go to database one and the fourth transaction will go to database two.
Two. Yeah.
So in a way, it will always function in an odd even fashion,
Yeah.
right? So one database would always be odd and one will always be even.
Yeah.
Now, if one of my database goes down,
Okay.
okay, so in that case, how my entries, like how my code can retrieve those entries, like let's say my second database goes down. So how will I get those odd entries? Are we copying, like is it a replication setup as well?
Yeah, it's a replication setup, right? It's a complete replication setup. Yeah.
So we are using double space. Like we have three servers and the disk space should also be like equally divided amidst them.
Yeah. Exactly. So it's a when you say replication, right? A
Uh-huh.
replication is a redundancy. That's a very first line. Like
Mhm.
here, it's not like a hardware-based solution. So it's a redundancy. So your data set in server A should be equal to the B and C. So all the three are equivalent data sets.
So
Okay.
even if at the night time one of my database goes down, I do not actually have to do anything. The switchover will happen automatically on its own.
Automatically, exactly. If you have proper load balance settings and everything, then the switchover
Uh-huh.
will happen automatically.
And my another question is, if my load balancer is on database two, like load balancer would be an application which would be installed in any of these three servers, right? And that very server goes down, then
It's not recommended to have the load balancer within the DB server.
Mhm.
But if there is a need, then you can consider thinking about having the LB in all the three and clustering it or having a virtual IP on top of it. Okay, so there can be solutions, but it's not a good practice to have the load balancer with the DB server in all cases. Or else you can have it in the application server if it is a one or two application, right? Then you
Mhm.
can have it within the application also. So that can solve the problem.
Okay, perfect. Just last point. You mentioned something about that there is some kind of compression which is available in MySQL version 8. What was
Yeah,
that? Could you please
yeah,
elaborate a little?
that was binary log compression.
Binary log
Yeah,
compression.
yeah, binary log generation will be more, right? So you can compress it because they also transfer over the network. In case of a
Mhm.
weak network, that really helps a lot.
Uh-huh.
Yeah.
Okay, perfect.
Okay.
Thank you.
Yeah. Thank you, Vibhor. Yeah.
Thank you so much.
Thank you.
Thank you, Karthik. Thank you, Vibhor. Okay, I think all the questions has been answered so far, and I'm pretty sure all the attendees might have upcoming questions. So please reach us out through an email by connecting to us at info@mydbops.com. And we also have a lot of upcoming webinars which we are intent to do every month, and it will be on a fixed slot of on a Saturday, which is at 11 a.m. But if there is any deviation from the slot, if we have a holiday which falls in on that day, then definitely that will be intimated in our official LinkedIn page. And apart from this, we also are planning for a database meetup, which is tentatively going to fall on Jan 23rd. And we are expecting not only internal speakers, but also renowned speakers from different organizations who are working from Google. So it is going to be a great meetup, which is going to be lined up for our open source community. And more details about this, which includes the speakers, all the details will be updated very soon on our LinkedIn official page and also the other social media pages. Thank you so much for being a great audience, and please write us if you have more questions, and we'll be very glad to have you have it answered all. Thank you once again. We'll see you in our meetup.
Yeah. Thank you, man. Thank you, everyone.